Hello students, welcome back to the JEE Last Mile Preparation Series 14. Today we will take up questions number 27 and 28. But before I do that, by now you already know that I'm Sujata from CBSE NEET JEE Chemistry.in, and we are bringing you two questions every day until 4th of April to help students get that extra edge for their JEE chemistry exam preparation. To keep me motivated in this task, please hit the like button and don't forget to subscribe to my channel. Also, please visit my website. The link is in the description below. Let's get started. We continue with physical chemistry. So we have two chapters here. One question is taken from solid state and the next question, the 28th question, is from the topic surface chemistry. Both these topics you've studied in class 12, right? Not in your curriculum. Solid state may not be in your curriculum, but it's important for competitive examinations. All right. Here is question number 27. Let's first read the question. A solid substance consisting of A and B ions. A ions are the positive ions, the B ions are the negative ions, has a face-centered cubic arrangement of unit cells. Okay? The negative ions B occupy all the corners and the face centers. 50% of A are the positive ions, right? A are the positive ions. 50% of, here, the positive ions. Now 50% of the positive ions A occupy the octahedral voids and the rest occupy the tetrahedral voids. 1/4 of the tetrahedral voids are occupied. You have four options. Which amongst these four options is the correct formula of the solid substance? So that is the question. All right. So let's get into the details of this particular question. Let's understand this question first. Okay. So here we have a face-centered unit cell. Face-centered unit cell. Okay. That is the first thing to be kept in mind. All right. Now there are A positive ions and B negative ions, right? You've also been told that the B negative ions occupy the corners and the face centers of the unit cells, all right? Now you know that in one unit cell, okay, in one unit cell, there are 8 corners. Each corner of a unit cell is shared by 8 other unit cells. So what is the contribution of, so in one unit cell, okay, what is the contribution of the negative ions? And you know that the negative ions are occupying the corners and face centers. Therefore, the positive ions will occupy the voids. Okay, there are two types of voids, octahedral voids and tetrahedral voids. So right now we're focusing on the negative ions, the anions, which occupy the lattice positions, namely the corners and the face centers. Okay, so in one unit cell, the contribution of a B ion would be 1/8 into 8, because each corner is shared by 8 other unit cells, and that is equal to 1. All right. Similarly, each face of a unit cell is shared by 2 unit cells. So let's try to get the picture of a unit cell here, just a cubical representation. So here we have a cube, right? Here we have a cube. Now these are the corner positions. These are the corner positions, all right? So these corners are occupied by the negative ions. Apart from the corners, the center of every face is also occupied by the negative ions. And there are 6 faces. This is the understanding of the cubic unit cell. You are aware of this, right? Okay, let's come back to our discussion. So now, what is the contribution of, in one unit cell, what is the contribution of, this is towards corners. Next is contribution towards face centers. since each face is shared by, two unit cells, okay? This face is shared by, another unit cell. So two unit cells are sharing this face. So there are six faces. Each face is shared by two unit cells. So what is the overall contribution? Half of 6, and that is equal to 3. All right. So which means in one unit cell, the number of the B negative ions would be 1 plus 3 equal to 4. There are 4 B minus ions in that unit cell. So 1 comes from the contribution towards the corner positions, and the 3 comes from the contribution towards the 6 face centers. All right. So there are totally 4 B minus ions. Okay. Now let me remind you about the relationship between the number of anions and the number of voids. Okay. So anions, octahedral voids. I'm not discussing the details of the formation of these voids. And then we have the tetrahedral voids. Okay. Now if there are, let me use a different color. Yes. So if there are n number of anions, there are equal number of octahedral voids and twice the number of tetrahedral voids. Okay. So now we know that there are 4 anions, right? There are 4 anions. Let's go back to the question. Let's focus on this information here. 1/4 of the tetrahedral voids are occupied. So if there are 2n tetrahedral voids, so here there are 8 tetrahedral voids, 2 into 4, correct? 2 into 4, 8 tetrahedral voids. 1/4 of those tetrahedral voids are occupied by the positive ions, namely the A positive ions, which is 2. All right. So you have 2 A ions occupying the tetrahedral voids. Okay. 2A occupying the tetrahedral voids. Now, what about the octahedral voids? It is mentioned in the question that 50% of A occupy the octahedral voids and the rest occupy tetrahedral voids. So equal number of A positive ions are occupying the tetrahedral and the octahedral voids, right? So if there are 2A positive ions occupying the tetrahedral voids, there are 2A positive ions occupying the octahedral voids. So there are 4 B anions and totally, so there are number of anions. Let's make a list here. Number of anions are 4 and number of cations are also 4. So what is the formula? What is the ratio? AB. The ratio is 1:1 and therefore AB will be the formula of the substance. Okay, so let's go back to the question and see which one amongst the 4 options is the correct answer. The correct answer would be option C, AB. Okay, this was one question from solid state. Now let's move on to question number 28, where we have a question, a conceptual question from surface chemistry. All right, there are so many concepts in surface chemistry. Most of them are conceptual questions. Okay, now let's read question number 28. When an excess and a very dilute solution of aqueous potassium iodide is added to a very dilute aqueous solution of silver nitrate. So let's focus on potassium iodide and silver nitrate. The colloidal particles of silver iodide, which are associated with the Helmholtz double layer are. 4 options have been provided. One amongst the 4 options would be the correct answer. Let's understand this question first. Okay, and let's also understand the concept behind this question. Now here, this particular discussion deals with the formation or the occurrence of charges on colloidal particles. Okay, occurrence of charges on colloidal particles. All right, charges on colloidal particles. Here, which colloidal particle or which colloidal sol is being produced? Silver iodide is being produced. So silver iodide is the colloidal sol being produced. Okay, And how is silver iodide produced? Silver iodide is produced by adding potassium iodide dilute aqueous solution to silver nitrate aqueous solution till potassium iodide is in excess. So all this information has been conveyed to us in the question. Okay, there's excess potassium iodide. So potassium iodide is added to silver nitrate solution till potassium iodide solution is in excess. Okay, so what is formed? So let's discuss the formation of the various layers. Okay, so here we have the silver iodide particles are formed. Okay, silver iodide colloidal particles are formed. Now the ion common between the silver iodide colloidal particles and the excess electrolyte potassium iodide are the iodide ions, because of which the silver iodide colloidal particles will preferentially absorb the common ion, the iodide ion on its surface. So the iodide ions are adsorbed preferentially on the surface of silver iodide. Why iodide ion? Because focus on the excess electrolyte. The excess electrolyte is potassium iodide, and the ion common between the colloidal particle silver iodide and the excess electrolyte are the iodide ions. So the iodide ions are preferentially absorbed by the colloidal particles. And what does this result in? This results in the silver iodide colloidal particles attaining a negative charge. So a negative sol is prepared in this manner. Okay. Now, apart from the excess iodide ions, there are also excess potassium ions. So now what will happen is the iodide ions, okay, the iodide ions will now attract the oppositely charged ions, excess ions, the counter ions, namely the potassium ions. Okay. Now the iodide ions form the fixed layer, all right, and the potassium ions form the mobile layer or the diffused layer. In this manner, a double layer is being formed with opposite charges. We call this as the electrical double layer. This electrical double layer is what is referred to as the Helmholtz double layer. Okay, this is how the Helmholtz double layer is created. Now, because of the positive and negative charges in the double layer, a potential difference is developed, and that potential difference is what we call as the zeta potential. So you should be aware of all these terms. Okay, but we have got the answer. The answer would be silver iodide absorbing iodide ions in preference and the iodide ions attracting the positive ions. All right. So this is the final answer to this question. So let's see which amongst the four options corresponds to this particular result. So here you have option D, right? You have got option D, silver iodide attracting the iodide ion, which in turn attract the potassium ions. All right. So I hope you've understood the concept behind these two questions, one from solid state and one from surface chemistry. If you found today's video useful, please hit the like button and don't forget to subscribe to my channel. Also, please visit my website. The link is in the description below. See you tomorrow.